Hey guys, today we are going to have a look at 01 knapsack problem. Given weights and values of n items and weight capacity W of a knapsack, find maximum value that can be achieved by selecting a subset of items. 01 means that we can't break the item, we either take it or leave it. For example, if we are given following weights and values and the capacity of the knapsack is 5, then the best we can do is 260, and that is by selecting 1 and 1 and 4. Now let's see how we are going to basically solve this problem. I have already set up my main function in order to test our functionality. Let's see how we are going to come up with the solution. The first thing that we are going to do is we are going to implement a recursive solution. Okay, so the first thing that we need to think about is that how we are going to approach this, right? And simply, if we are given a capacity, that means that there are two things that we can do. Either we can say that we want to take this item, right? Or we can say that we don't want to take this item. What that means is, if the weight of the item is less than the capacity, we say that we actually want to take it. And what that means is that we are going to take the value and add it to the result of a new recursive call, which is going to say that I have left with n minus 1 items, and my new capacity left is whatever capacity I had right now minus the weight of the item. Okay, so that way our new call will try for the remaining capacity and remaining items. And second thing that we can do is we can say that we don't want to pick this item at all. Okay, and we do that by simply saying that my capacity remains the same, but I want to try for the lower items, right? So that is the way how we are going to solve this. So for example, say our capacity is in the beginning 5, and then we say that if we can take 4, right? 4 must be less than our capacity, which is true over here. We say we take it, right? So our current value should be 200. Okay, and then the remaining capacity we have is 1. So we make a recursive call. Then of course 3 cannot be taken, and 2 cannot be taken, and then 1 can be taken. So we add 60 to it, and after that, right, n becomes 0. So our value remains 200 plus 60. Similarly, when we say that we don't want to pick 4, what we say is take 5 and start with 3. Okay, and the same process goes on, right? And these two different calls will give us two different values, and one will be better, and that is the one we want to take. Okay, so that is the fundamental idea. Now let's see how we are going to implement it. Okay, so name of our function is knapsack, which takes 4 parameters. Okay, so this is how our solution is going to look like. First thing we say, basically we are going to subdivide the problem, and we want max of it. Okay, so first thing that we say is we take the value. Basically we are taking the item, right? So our call will look something like this. Okay. Here we say that we take it, right? And second call is we say that we don't want to take the current item. Okay, so this is basically subdivision. We said that we want the value, and then we say that my new capacity is c minus weight, and number of items left is n minus 1. And we say that we don't want to take the current item, which means that we just want to reduce the number of items that are available to us. And one more thing we want to do is we want to ensure that we make this call if and only if the capacity is actually more than the weight of the item that we are looking at right now, right? And we do that by checking if okay, if weight is actually greater than capacity, which means that we cannot take it, right? So we just make a call by saying that I still have capacity left, try with the lower items if we can get that. And then we need boundary condition. Okay, if first of all n equals 0 or c is less than equal to 0, basically equals 0, then return 0. Let's think about it. If we need equal or less than, say we have some capacity, okay, and we are basically negating the weight if and only if weight is actually greater than c. If greater than c, then we just continue with the c, and otherwise we take it. So possibility of c getting less than 0 is not possible. So this condition is correct, right? Let's see if it works fine. Cool. So our recursive solution is working fine. Now let's see how we are going to implement an iterative solution for this. Okay, so before actually implementing, let's see how our approach is going to look like. Okay, so this is actually for example, we are going to do the calculations that we are going to do in our implementation. Okay, here what we have is these are the capacities, okay, and these are the weights, and these are the values. All right, here we start at index 0, and there's a reason for it. You will see in some time that why we need it. Okay, so for 0th index we'll have all zeros, okay, because no value associated with it. Then for 0 it is going to be 0. 1 minus 1 is 0. What that means is that we are saying that we want to pick this item, okay, and after picking this item, we want to check if we have any items below it that we can pick, that we can actually pick and have some value with that, right? So what we do is we subtract 1 from 1, we get 0 index. we go one level up, which means that by from remaining items see if we can get zero value from if what value can we get at the zero index, right? So that is the idea, and we add that particular value to the value of the picked item and compare it with the uh, value that we had with the uh, previous items, right? And that will be stored one level above. Okay, so here we are going to have 6, right? And it is going to be for all of them. Okay, 5 minus 1 is basically 4, and 4 at 4 we have 0, right? So 6 plus 0, we got 6, which is better than 0, right? Now for the next level, here we'll see what we have been talking, right? I mean, the basically if we pick the item, then we have to see if we can pick the item from below. All right, so here we cannot pick 2, right? So we take the value from above, and here 2 minus 2 is 0. Okay, and one level above and at 0 we have 0, so best we can do is 10 over here, because 10 is greater than 6, right? So we take 6. Now 3 minus 2 is 1. Okay, what that means is we are going to take this value and one level above and go to 1 and add this value to this value, so it is going to become 16, and 16 is of course better than 6, right? So we are going to take 16 over here, and same thing will apply for 4. 4 minus 2 is 2, and one level above and at 2 we have 6 over here. Okay, and same thing will apply for 5. Let's see for weight 3. Okay, this is going to be 0, this is going to be 6, this is going to be 10, and here if we pick this item, right, 3 minus 3 is 0, we go one level up and at 0 we have 0, so the best we can do is 12 plus 0 by selecting this item, but it's not better than 16 over here, right? So what we do is we keep it 16. With this, 4 minus 3 is 1. Okay, and if we go to 1 level above, we have 6 over here, we add it to 12, we get 18. Okay, and similarly if we subtract 5 from 3, we get 2, we go to 2, we have 10, 10 plus 12 is 22, which is better than 16, right? Now pretty much the same thing happens. Okay, 4 minus 4 is 0, we have 20, 20 is better than 18, we get 20 over here, and 5 minus 4 is 1, at 1 we have 6, and 20 plus 6 is 26, which is better than 22, right? So that is the whole idea, right? Basically what we want to do is we are doing pretty much the same thing that we did in our recursive solution, but what we are saying is that, you know, we either take the value from previous calculation, or we pick the item and see if we can get any value by, you know, picking this item. And how we do that is basically we take the capacity, subtract with the weight, and whichever index whichever capacity is left, we go to that particular index one level above and see if we have any value. We add that value to the value of the picked item and we sum it up, and if we check if it is better than the previously calculated value, right? If it is, we take it, otherwise we keep our previously calculated value, right? So that is the idea for iterative solution. Now let's see how the implementation is going to look like. Okay, so let me copy the name of the function pretty quickly, and here we are going to require an auxiliary array. For iterating, we need 2 loops. Okay, here we are starting at 1 basically in order to keep our code clean, right? If we had started at 0, what that means is that this particular row will not be there. Okay, and we want this in order to ensure that we have something above this particular row, right? When we are considering 1, then 0 exists and we can actually get values from 0, otherwise we have to make extra provisions, right? So we don't want to do that. All right, now here there are two cases, right, as we discussed. One is if we can pick the item or if we cannot pick the item. Okay, so let's take first thing. If wi minus 1 is actually less than equal to taken weight, okay, taken capacity. In this particular case, what we want to do is we want to save the result, right? Here we are going to say that if we pick the item or if we don't pick the item, which one is better, give me that, right? So here we are going to take max of if we pick the item, it means we are going to sum it up with the value which we can do by basically with the previous values and the remaining capacity. Okay, so that is what we are doing over here. Or if our previously calculated value was better. Okay, so this is the case when weight is actually 0. Otherwise, we take the previously calculated value. So this is basically pretty much it, and our solution would be at here. Okay, so this is the solution, right? Let's see if it works fine. Okay, we need an auxiliary array over here. Let me just copy it quickly. Here our n is 5 and m is basically size of the array. So what we need to do is here we need to do this. And we paste 0 over there. Okay, and all we need to pass over here is auxiliary array, and let's see. So cool, our solution is working fine. If you need the code, I'll be sharing a GitHub link in the descriptions, and yeah, that's it. Thanks for watching.